Hello, everybody. I hope you guys are all doing well, and I miss you guys. Today, we're going to be looking at the beginning of chapter 9. So, rather than go through a bunch of the problems in the book and all of that kind of stuff, we're keeping it really short and simple. We're just going to look at how do we do these problems and what do they end up looking like. So, there's a good pencil. We're going to start off actually by remembering how to solve regular equations. So let's say I've got something like 3x plus 4 equals 2x minus 1, right? In order to solve this, I have to get my x's all on one side. And so I've got an x plus 4 is equal to negative 1. Now that my x's are together, I need to get rid of this plus 4. And remember, in order to do that, we have to think about undoing what was done, right? We don't just want to flip the 4 over there. We want to think about how can I undo a plus 4. The opposite of adding 4 is subtracting 4 from both sides. So I end up with an x is equal to negative 1. We've looked at more complicated equations to solve, so it might be something like a 2 times m minus 4 is equal to 3 times 2m plus 1 minus 4, right? So here we've got some things that we need to simplify first. Can just distribute that through. So 2m minus 8 is equal to, distributing this one through, 6m plus 3, and then that minus 4 hangs out in the back. I'm going to combine like terms here. So 2m minus 8 is equal to a 6m minus 1. I'm going to get my m's on this side because that way they'll still be positive. You could also move them over to the left. We'll look at that in a little bit. With the problems that we're going to do, it's going to just be a lot easier if we always have a positive number in front of our variable. So I'll have negative 8 is equal to 4m minus 1. Add 1 to both sides. Remember getting rid of that piece. Negative 7 is equal to 4m. Hold on one second, I'm going to sneeze. Maybe not. Okay. So I can divide both sides by 4, and I get that m, goodness, okay, m is equal to negative 7 over 4. Okay, so when it comes to solving equations, hopefully this type of thing is what you're familiar with. What we're going to look at today is something that's a very slight extension on that. It's nothing crazy. We're going to be looking at solving not equations, but instead inequalities. Okay, let's remember what our inequality symbols are. Inequality symbols. So we've got, this is less than. We've got less than or equal to. Oops. We've got greater than. And then we've got greater than or equal to. Now, when we're looking at this idea of less than and less than or equal to, all that it means is if it's or equal to, it could include that boundary point. So I'm going to look at a couple of really basic inequalities to solve. We're going to graph them on the number line, and then we'll look at kind of complicating the process a little with a little bit more complicated problems. So let's start off with something like this. Let's say I've got 2x is less than 10. Now, if I was to give you the equation 2x is equal to 10, what would you do to solve this? Just take a moment and think about what would you do to solve this equation right here. Hopefully you're thinking to yourself it's being multiplied by 2, so I would divide by 2 to get my answer, and x would be equal to 5. Here, it works the same way. With inequalities, there's only one small difference, and I'll show you here in a little bit, but as we're working with this, the only thing that we have to do as we are trying to get x by itself is we follow the same steps. They're very, very much like solving equations. If you treat them the same way, you'll do very well. So I've got that x is less than 5. And let's take a minute to really think about what x is less than 5 really means. If I'm on a number line, I'm going to go with 0, 1, 2, 3, 4, 5, 6. Right? If I'm on a number line, I'm thinking about all of the numbers that are less than 5. So 1 is less than 5, 2 is less than 5, 3 is less than 5, 4, 3.5 is less than 5, 2.5, right? 2 3/4, 1 3/4, right? Really anything here, anything going this direction is less than 5. All the way up to, but because it's not equal to, it's just up to and does not include it. The way that we show that is with an open circle. Right? An open circle tells us that it goes all the way up to that point, but does not include it. So right here with less than or greater than, I'm going to put open circles. Big opens. Okay? Now, if I was to change this inequality, if I was to change it and have it be a greater than, or sorry, less than or equal to, then what I've got is I've got that it does include that point, and so then that changes it to a closed circle. Circle. Sorry. So it changes it to a closed circle if I've got this less than or equal to. The way I like to think about it is it's got that extra piece at the end, so that means I fill it in. Right? It's got that extra piece underneath. That means I do a little bit extra and I fill in my bubble. Okay, let's look at another one. Let's look at a 3 is less than 4x plus 2. Okay, so for this one, I'm going to get my x by itself, right? The process is still the same, so I'm going to subtract 2 from both sides. So I've got that 1 is less than 4x. To get my 4 by itself, I now need to divide both sides by 4. It's not going to go in evenly, but that's okay. So I've got that 1/4 is less than x. Okay? So I'm going to go ahead and put my number line here. 1, 2, and then -1. So 1/4 is right about here. Notice when I'm doing my number lines, are they super duper accurate? I'm just trying to get an idea as to which direction I'm going to shade. In this case, I know x is greater than 1/4. Notice I'm reading it kind of backwards. 1/4 is less than x. I'm going to go up here. That also means that x is greater than 1/4. If I flip the whole thing, I have to flip the sign so that it still is that my bigger one is my x. So if my x is on the left-hand side, then I can treat this like an arrow telling me which direction to shade. But notice that only works if my x is on the left. With my x over here on the right, it doesn't quite work. You don't have to change it so that your x is on the left, but what you can think about is that this number is bigger than that one. So I'm shading to this side. You can also plug in some points to see what works. I could plug in a 2, and does it make it true? Is 2 greater than 1/4? Yes, so that means that I would shade everything on this side. Okay? Let's look at another one. Let's look at the situation where things get a little bit different. Let's say I've got a -2 plus 3 is less than 7. Sorry, that took me a minute. All right, so for this problem, I'm going to treat it the same way for the first couple steps. I'm going to subtract 3 from both sides. So -2x is less than 4. Now, this is the one time where things are different. This is the part where we need to pay close attention. Right? Everything up until this point is the same. It's just like you're solving an equation, right? This is the part where things are different. Here, I'm going to have to be dividing by a negative number, right? I myself, the person solving the equation or the inequality is doing an action where I'm multiplying or dividing by a negative number. So multiply or divide by a negative. I'm the one doing it, right? So because I'm the one multiplying or dividing by a negative number, I'm going to divide both sides by 2. This is by -2. This is the only time where things are different. Because I'm effectively flipping this from a positive to a negative. I'm flipping this from a positive to a negative. I also need to flip my sign. Okay? Because if a -2x is less than 4, well, that's the opposite, right? If the opposite is less than, then once I flip it and make it positive, then it's going to be greater than. So x is greater than a negative 2. Okay? So looking at my number line, negative 2, negative 3, negative 1, 0. Negative 2, I have an open circle at negative 2, and I'm going to shade that direction. Okay, now let's just double check and make sure that this works, right? Because I did this weird flip thing, so I want to make sure that it works. So let's say I plug in 0, right? 0 is a number that it's shaded, so it should make it true. Everything on this side of negative 2 should make my inequality true. So if I plug in a negative 2 times 0 plus 3, is that less than 7? Well, is 3 less than 7? Yep, it works. Okay? So let's look at the problems that you've got for your homework. So these problems right here, this is all that you've got. You've got 15 problems, and all that you're doing is solving. I'm going to do a couple that look like these ones right here where there's some fractions thrown in just to make sure you understand them, but there's nothing crazy going on. There's these answers right here. They give you the answers. The other thing that I've uploaded are these, okay? Notice they're the same problems, but they're my worked out solutions so that you'll be able to look at the step by step. Okay, copying it is not going to do you much good when it comes time to take a test, right? So you want to make sure that you're using those as a way to help you, not just a way to get the work done. So I'm going to look at one. In fact, I'm not going to do one from your homework because I've already done them. They're already worked out. So I'm just going to give you one that's kind of similar. Let's say I've got an x plus 3 all over 4 is less than or equal to a negative 6. Okay? So for this one, I've got this weird fraction thing here, right? And if we remember, if I want to get rid of fractions, what can I do? What do I do if I want to get rid of fractions? Well, I can look at the denominators, right? This is over 1. I can multiply everything by a common denominator. So if I multiply everything by 4, then I can get rid of my fractions. So I can multiply this one by 4. Those cancel. So I've got an x plus 3 is less than or equal to, here, the 1 doesn't cancel with anything, a negative 24. So I can subtract 3 from both sides. X is less than or equal to a negative 27. Okay? So even though those fractions show up, they're nothing to worry about. Okay? Same thing with, like, if you look at number 14 and 15. Let me zoom in here for you. Number 14 and 15, all that you would have to do is multiply by, in this case, 15, right? Your 5 would cancel here, so you'd have to distribute a 3 through. Your 3 would cancel here, so you'd have 2m times 5, okay? Remember, if you have any questions or you need any more help, let me know. But really the process for these things is it's not anything super crazy or complicated. You're still solving equations just like you did before. The only difference is if you multiply or divide by a negative number, if you are the one taking that action, you're multiplying and dividing both sides by a negative, you're also taking the opposite of your sign. So you have to remember to flip your sign, okay? Remember, let me know if you need anything. Please reach out and have a wonderful day.